Alright, we'll be looking at applied mechanics for engineers, and we'll be considering the topic equilibrium of a particle in space. Equilibrium of a particle in space. Okay, now let's look at this diagram. The diagram is showing us a wall. It shows us a wall, and we see the dimensions of this wall. Over here you have 8 meter, and then here you have 10 meter. Okay, then from point B going downwards we have 1.2 meter. Okay, and then we also see that distance between this middle side of the wall and point A is 1.2 meter, and the mass is 200 kilogram. Then we have a force P acting this way. Distance between the force P and the horizontal axis X is 2 meter. Alright, the question says a 200 kilogram cylinder is hung by means of two cables, AB and AC. These are the two cables, cable AB and cable AC, which are attached to the top of a vertical wall, full stop. The horizontal force P perpendicular to the wall holds the cylinder in the position shown. Determine the magnitude of P and the tension in each cable. We're asked to determine the tension in each cable. So let's look at that quickly. You will first draw a free body diagram. Draw the free body diagram before you start solving. Alright, now this is our free body diagram. This is the free body diagram. Okay, we come back here. This is the point A and B. So this wire or this cable is cable AB, and this is cable AC. And along cable AB, we have the unit vector lambda AB, and we also have the tension force tension AB, TAB. Okay, then we have the unit vector lambda AC along cable AC and the tension force TAC. Alright, and then we also observe that force P is acting this way horizontally. Then we look at the coordinates I, J, and K coordinates. J is acting along the y-axis, I is acting along the x, and K along the z-axis. Okay, then we'll first find the weight of that body, 200 kg body. So the weight of 200 kilogram block cylinder, right? 200 kilogram cylinder. So W is equals to mg, as W will be equals to 200 kg times acceleration into gravity is 9.8 meters per second square, and when you multiply them, you'll be having that W is equals to 1960 Newton. Alright, so we have gotten the weight of 200 kg cylinder, and this is it. W equals to 1960 Newton, and the weight must act vertically downwards. The weight of a body must act vertically downwards, so W is equals to 1960 Newton. Okay, so after obtaining the weight, we will then look at equilibrium conditions. Equilibrium conditions shows us the summation of the forces acting in that system. So we'll take the equilibrium conditions. Okay, say equilibrium conditions. So the first equilibrium conditions there shows us the summation of all the forces acting on that wall. We take the summation of all the forces. That is the resultant now. The resultant arrow will be sigma F. Sigma F now will be, take the first force, tension AB. Okay, it is a vector. Tension AB is a vector. That's why we represent it with that arrowhead. Tension AB plus, take the next one, tension AC. That's also a vector. Tension AC plus, take the weight, represent the weight as a vector, and then finally take the force P going this way, represent it as a vector as well, plus P. Alright, of which you can call this one equation 1. Call that equation 1. Alright, okay, so that is showing us the summation of all the forces acting on the wall. This is it. Okay, TAB plus TAC plus the weight plus the force P. Alright, then we'll continue. We'll then, now the next thing we'll do is to consider cable AB. Consider cable AB. Says consider cable AB. Consider cable AB. Now we'll look for the position vector of AB, the distance. Position vector RAB will be equal to, okay, let's come back to the free body diagram. Now, the first thing you will do there, you observe how it is being positioned with respect to I, J, and K coordinates. Okay, so you start moving from point A. You move from point A until you get to point B. So let's go down. You go down like this. If you're coming down, it is minus 2J. This is minus 2J. Minus 2J. Because we are coming downwards. Come down like this, is minus 2J. Then you go like this. Go like this. You have, if I go like this, I will have, you observe the distance here is 1.2. Now you are going against x. If you are going against x, it will be minus 1.2 I. Okay, so let me explain that again. First, I move down. Now if you are going up like this, up is plus j. If you go like this, it's plus k. If you go like this, it's plus I. Okay, so let's come again. From A, I come down like this. That is minus 2J is coming down. Then I go like this is minus 1.2, because it's going like this. Minus 1.2 I. Okay, then I'll move like this. I'll move this way. I'll move like this. Okay, observe, if I go this way, that is plus 8K. If I go this way, this is plus 8K. Plus 8K. Okay, so from here now, from here I'll move like this with respect to this 8. Go like this, plus 8K, and finally I go up, plus 12J, upwards, plus 12J. That is plus 12J. Alright. Okay, so let me repeat that again. That's the most crucial and sensitive part of this topic. Okay, let's find RAB again. Let's go. Now look at this. From point A, if I come down like this, with respect to this distance, if I'm coming down, it is minus 2J. Coming down, because if you are going up, it's plus J. If you come like this, plus K. If you go like this, plus I. So if I come down like this, it is minus 2J. Okay, then I will go like this again. If I go like this, it's opposite I. If I go like this, with respect to this distance, to be minus 1.2 I. Okay, then I will come this way. If I go like this, with respect to this other distance, 8. If I go this way, I'll be having plus 8K. From here, I go down, that is plus 8K. Okay, with respect to K as this, then I go up until I get to point B. Go up, that is plus 12J. Okay, so that is it. Okay, plus 12J. Alright, then I'll then rearrange it. I'll be having what? RAB distance RAB equals to, I'll take minus 1.2 I, then minus 2J plus 12J plus 8K. Okay, So minus 2j plus 12j is 10j. So I'll be having arrow AB equals to minus 1.2i. Minus 2 plus 10 is plus 12 is 10. That's plus 10j plus 8k. So that is arrow AB. So my position vector arrow AB is minus 1.2i plus 10j plus 8k. Okay, then I will then look for the modulus of the vector. The modulus is also known as the magnitude. Using Pythagoras rule. To obtain the modulus, use Pythagoras rule. This is square root of minus 1.2 all square plus 10 all square plus 8 all square. And this will give me, say, square root of, with your calculator. So this 1.2 square is 1.44 plus 10 square is 100, 8 square is 64. Okay, so if I add them now, this will be square root of, this is square root of 165.44, of which when I find the square root, so when I find the square root, I'll be having 12.9 as RAB modulus. So the modulus of the vector is 12.9. The next thing I will look for is the unit vector lambda AB. I will obtain the unit vector lambda AB. So lambda AB will be equals to the position vector RAB over the magnitude. Alright, this now will be, say, lambda AB. RAB is, we had minus 1.2i plus 10j plus 8k plus 10j plus 8k over the modulus. Modulus is 12.9. Okay, so if I separate them now, I'll be having lambda AB. Lambda AB will be equals to minus 1.2 divided by 12.9 plus 10 divided by 12.9 plus 8 divided by 12.9. Okay, this is I, this is J, and this is K. Okay, so by dividing this now, I'll have lambda AB be equal to, if I divide, I'll have, so this is minus 0.093i plus, the next one will be 0.775g, and the next, if you use your calculator, we're having 0.620k. Okay, so those are the values. This is lambda AB. Right? Okay, so we have gotten lambda AB, which is the unit vector lambda AB. So let's consider the next cable AC. Okay, so you will consider cable AC. Consider cable AC. Okay, now look for the position vector AC. So the position vector AC is arrow AC. Arrow AC. Now, if you come back to this, let's come back to our diagram. Arrow AC. Now, from this point A, you move vertically downwards. So move vertically downwards. This is it. Okay. If I come down like this, that is minus 2j. Okay. I go like this. It is minus 1.2i. Okay. I go like this. It is plus 12j. And then I go like this. It is if I go like this, it will be minus 10k. Okay, so let's go. Let's go. I come down, minus 2g. I'll take that. That is minus 2g. Then I'll take the next one. Okay, minus 2g. I take the next one, going like this with respect to this. Okay, that's minus 1.2i from here, minus 1.2i. That's minus 1.2i. Minus 1.2i. Okay. Okay, minus 1.2i. Then I go upwards like this with respect to this 12. Go upwards, that is plus 12g, and then finally I go like this. It will be, this is with respect to k, it's going opposite k. If I go like this, it will be minus 10k. Okay, so that is it, plus 12g minus 10k. This is plus 12g minus 10k. Alright, so that is it. And I then continue. If I arrange it properly, that is RAC will be, take that of I first, I have minus 1.2i. Okay, and I take the next, minus 2g. I take the next plus 12g. Okay, and I take the next minus 10k. Alright, that is minus, if I arrange it properly, minus 1.2i minus 2g plus 12g minus 10k. Okay, if I do that now, this is RAC position vector equals to minus 1.2i minus 2 plus 12. Minus 2 plus 12 will give me plus 10. Plus 10g minus 10k. Okay, so I've gotten that. And then the next thing I'll look for is the magnitude. After getting the position vector, I then look for the magnitude. So it says magnitude or the modulus of the vector RAC using Pythagoras theorem. I have square root of minus 1.2 all square plus 10 all square plus minus 10 all square, and this will give me the square root of, okay, so this now is 1.44 plus 10 square is 100, and minus 10 square is also 100. If I add them, I'll be having the square root of, if I add them, I'll be having 201.44. Okay, and the square root of this is equal to 14.2. This is the modulus RAC. Then I can then look for the unit vector lambda AC. So unit vector lambda AC will be the position vector RAC divided by the modulus RAC. Okay, so this now will give me the position vector RAC is, remember we had the position vector RAC as minus 1.2i minus 2g, minus 1.2i plus 10g minus 10k. That's minus 1.2i plus 10g minus 10k all over. This one is giving us 14.2. That's 14.2. So if I separate them now, I'll be having lambda AC is equals to minus 1.2i divided by 14.2 plus 10g divided by 14.2 minus 10k divided by 14.2. So if I divide them now with my calculator, I'll have the lambda AC. Using your scientific calculator, if you divide, you have, this will give me minus 0.0845i, and this will be plus 0.7042g minus 0.7042k. okay, 0.7042K. Alright, okay. So we then go back to cable AB. You go back to cable AB and you say that the vector TAB is equals to tension AB times the unit vector AB, lambda AB. Okay, so the vector TAB will be equals to tension force AB times the unit vector. We had the unit vector as minus 0.093i. Okay, we'll take that quick. This is minus 0.093i plus 0.775j plus 0.620k. Okay, so if I expand it now, by expanding this, TAB times this will give you minus 0.093 TABI. This times this one will give you plus 0.775 TABJ, and this times this will give you plus 0.620 TABK. Okay, so this is the tension force TAB. Okay, we have gotten the tension force in AB, of which we can call this one equation 2. We can call this equation 2. Alright, call that equation 2. Then we would also consider that of cable AC. It means that the tension force AC, the vector TAC, will be equals to tension AC times lambda AC. Okay, tension AC times lambda AC. Alright, and then we'll quickly do that. Continue. Say tension AC, vector TAC will be equal to your tension force AC times, we'll put the value of lambda AC. We had lambda AC as this on a 0.845i plus 0.7. Okay, so we'll put it there now. We're having, so I'll have minus 0.845i plus 0.7042G minus 0.7042K. Alright, okay, this is 0. So if I multiply this now, this will give me minus minus 0.845 TACI plus 0.7042 TACG, then times this one minus 0.7042 TACK, which we can call this one equation 3 as tension force TAC. Alright, now the next thing we'll look at, after finding tension force TAC, we'll get the weight out of the weight. So we took this weight as a vector, and if it is acting downwards, it will be minus WJ. So since J is going up like this plus J, if it's going downwards opposite J, it will be minus WJ. So it means that the weight, the vector force weight will be equals to minus WJ. Okay, you can call this one, I call this equation 4. Okay, then we'll take that of the force P. Force P is going like this, directly on the x-axis, so it's going this way. So I'll take that. I say vector force P will be equals to PI. Okay, I can then call this equation 5. And next thing I'll do now is to then input the values. I say substitute equation 2, 3, 4, and 5 into equation 1. Okay, so equation 1 then changes to, you say my resultant force will be, okay, so the resultant force now, arrow, which is sigma F, will then be equals to, first put equation 2. Equation 2, we had equation 2 as this. So I'll put it inside into that equation, and I'll have, if I substitute that, I'll be having minus 0.093 TAB I plus 0.775 TAB J plus 0.620 TAB K. Okay, so I have this. Then I'll add it to the next one. Out of TAC, this is minus 0. This is that of TAC. Okay, this is the value, so I just put it into the equation. So maybe minus 0.845 TACI, and this is plus 0.7042 TACJ minus 0.7042 TACK. Okay, then I take that of the weight which is minus WG, to be plus open bracket minus WJ. Okay, I take that of the first P, and then first pass plus PI. Okay, then I'll then rearrange them properly. Arranging them properly, I'll have, okay, rearranging them properly now, I'll be having that sigma F equals to, take that of I, this is I, so I have minus 0.093 TAB, and then this is also I, that's minus 0.845 TAC. Okay, then I look for another I again, this is I, that's plus P. So if I add everything now, I have I. So I first took this minus 0.093 TAB, and I took this other one minus 0.845 TAC. Then I took this one plus P. Then let's take that of J. Okay, take that of J, that's 0.775 TAB. Okay, so I have plus 0.775 TAB. Okay, then the next J there is 0.7042 TACG. Okay, so I'll take it out, that is plus 0.7042 TAC. Okay, that is this one here, J. Okay, now then look for another J. The next J is minus WJ. Okay, minus W, present them with J coordinates. Okay, now look for K. K here is plus 0.602 TAB. I'm having 0.602 TAB. Then the next K, after this, the next K is this, minus 0.7042 TAC, minus 0.7042 TAC. Okay, then there's no other K again. I have K. Alright, so I will represent each of them properly, and this now will be, okay, so I'll take this one, which is I, that's sigma fx. I'll take this, that will be minus, the whole of this is sigma fx, then the whole of this is sigma fy with respect to J, and the whole of this is sigma fz with respect to K. So let's take that one out. I have that sigma fx will be equal to, that is minus 0.093 TAB minus 0.845 TAC, and then the next will be plus P. Right, which I can call this equation, 6. Alright, okay, then I'll look for sigma fy. Sigma fy will be equal to, I'm having 0.775 TAB, then plus 0.7042 TAC minus W, which I can call this equation 7. Okay, that's sigma F. Then I will take sigma FZ, sigma FZ. That is sigma FZ will be equal to 0.602 TAB, then minus 0.7042 TAC, which I can call this one equation 8. Okay, so that is sigma fx, sigma fy, sigma fz. Alright, so then it then implies that sigma f actually is sigma fxi plus sigma fyj plus sigma fzk. And then you observe that we have gotten the values of sigma fx as this, sigma fy as this, and sigma fz as this. So that is the explanation. It is the simple explanation of this sigma fz. So the whole of this you're seeing here is sigma fxi. The whole of this is sigma fyj, and the whole of this is sigma fzk. Okay, that's good. We'll take the next equilibrium conditions. The next equilibrium conditions is sigma fx equals to 0, sigma fy equals to 0, and sigma fz equals to 0, which is static equilibrium. Static equilibrium conditions. Static equilibrium conditions for bodies at rest. Okay, so if we apply that now, we apply that to both equation 6, 7, and 8. Equation 6 now we change. You have sigma fx will be equals to 0, which is equivalent to minus 0.093 TAB, and that one now will be minus 0.845 TAC, and this is plus P. Alright? Okay, so I'm having that. Okay, so then this other equation changes. That is sigma fy, which is equals to 0, will be, you write this down, that is 0.775 TAB plus 0.7042 TAC minus W. Okay, and that of sigma fz also changes. Sigma fz will be equal to 0, which is equal to 0.602 TAB minus 0.7042 TAC. Okay, so the equation changes. Alright, so we can then call this one, equation 9, equation 10, and equation 11. Alright, okay, so we come back to this. We say from equation 10, I'll be having 0.602 TAB minus 0.7042 TAC is equals to 0. So 0.602 TAB will be equals to 0.7042 TAC. Okay, and if I divide by the coefficient that's dividing by this, I have that TAB will be equals to 0.7042 TAC divided by 0.602. Okay, so TAB will be then equals to, if I divide this, I'll be having, okay, so this will give me 1.1358 tension AC. Okay, 1.1358 TAC, of which I can call this one equation 12. Okay, that's when I divide 0.70, this is 0.620, this is 0.620, 0.620. This was a slight mistake. 0.620. So when I make it subject of formula, when I make TAB subject of formula, I had this, okay, and 0.7042 divided by 0.620, and this gave me 1.1358 TAC, of which I can call equation 12. All right. Okay, the next thing you do is to substitute equation 12. Substitute equation 12 into equation 10. Okay, so I'll write down equation 10 out, and my equation 10 is 0.775 TAB plus 0.7042 TAC minus W is equal to 0. Okay. Alright, so I'll quickly substitute that. This will be 0.775. TAB is 1.1358 TAC. Okay, that's plus 0.7042 TAC minus the weight of that body. The weight of the body is this. Okay, from the free body diagram, this is the weight, and it's acting down, which is negative. That's minus 1960. Okay, and it is J, isn't it? Okay, but we don't need the coordinates for now. I'll be equals to 0. All right. So if I multiply this and this now, I'll be having, okay, if I multiply this, I'll be having 0.88025 TAC plus 0.7042 TAC minus 1960 equals to 0. And then if I add them, I'll have 1.58445 TAC minus 1960 equals to 0. Okay, so that is 1.58445 TAC. Okay, so if I divide that now, this is 1.58445 TAC. Carry this one over to this place. That's equals to 1960. If I divide by the coefficient of TAC, I have tension AC. TAC will equals to 1960 divided by 1.58445. Alright, and if I divide this, I'll be having TAC as, with a calculator, I'll have, if I divide now, I'll be having 1237.02 Newton. Okay, alright, so tension AC is 1237.02 Newton. Alright, so I've gotten that. I've got to the value 1237.02 Newton. Then the next one now I'll do is to find the other tension for TAB. So I say substitute TAC equals to 1237.02 Newton into equation 12. Okay, so I substitute that into equation 12, and then I'll be having equation 12 is TAB equal to 1.1358 times TAC, and value of TAC is 1237.02. So if I multiply this now, I'll be having 1405.01 Newton. Okay. Alright, so I've gotten the value of TAB. Tension AB is this, 1405.01 Newton. Alright. Okay, then I can then look for the force P. I say substitute the values of TAB and TAC into equation into equation 9. Okay, and this now is remember that equation 9 is minus 0.093 TAB minus 0.845 TAC plus P is equals to 0. Okay, so I'll put the values there, and in putting the values I'll be having minus 0.093 times TAB is 1405.01 minus 0.845 TAC. We had TAC as 1237.02 plus P is equivalent to 0. So if I multiply them now, I'll have we're having minus, using your scientific calculator, you have minus 130.665, and if I multiply this other one, I'll be having to give me minus 104.528. With a scientific calculator, you get that values as this times this will give you this. Okay, plus force P is equivalent to 0. Okay, so if I then tackle these two now, minus this, that's minus this value minus this, I'll have, okay, so this will give me minus 235.193, okay, plus P is equivalent to 0. Alright, then I can make P subject of formula. Take this one over here. I'll be having that P is equals to 235.193 Newton. Okay, final answer. So I've gotten the value of the force P. Okay, I've also gotten the value of tension force TAB, and I've gotten that of TAC, tension force TAC, as this. Okay, so that is the final solution to that question. Thank you. Where is it? And this other one. Okay.